Hello ma'am, praise be Jesus Mary. This video entitled How Could Trigonometry Help in Our Daily Lives? This topic we're supposed to discuss is a Pythagorean theorem. What is Pythagorean theorem? In mathematics, the Pythagorean theorem is also known as a Pythagoras theorem. It's a fundamental relation in Euclidean geometry among the three sides of the right triangle, but also applied in trigonometry. The theorem can be written as an equation relating to the lengths of the both sides of A, B, and C, often called the Pythagorean equation. The equation are a squared plus b2 squared is equal to c2 squared. B represents the length of the hypotenuse in A and B to the lengths of the triangle and other two sides. So here's the example of the Pythagorean theorem.
This tutorial is going to introduce you to the Pythagorean theorem and show you a couple of examples using it. Pythagorean theorem simply states that in a right triangle, c squared equals a squared plus b squared, where c is the length of the hypotenuse and a and b are the length of the other two sides. Now there's a couple of terms I just want to quickly recap for you. A right triangle is a triangle with a 90-degree angle. So if I had this triangle here, if I label this as a right angle, which is 90 degrees, we could call this a right triangle. Another term is the hypotenuse. A hypotenuse is always the side across from the right angle. So I have my 90 degrees. If I were to draw a line opposite that 90-degree angle, this is my hypotenuse. I'm going to label that HYP for hypotenuse. Now, if I wanted to label this as my A, B, and C, I know C is the hypotenuse and A and B are the other two sides. Now, it doesn't matter which one you label as A or which one you label as B, as long as you have that C as the hypotenuse. That's the important one. Let's look at an example. Solve for x using the Pythagorean theorem. Okay? I need to find my hypotenuse. So I'm going to look for my right angle and look opposite for the side and label that C. So that's my hypotenuse. The other two sides I'm going to label A and B, and again it doesn't matter which one is which. Remember, the formula for Pythagorean theorem is c squared equals a squared plus b squared. I'm going to sub in the values that I know. Well, c is just our x, that's what we're looking for. A is 3. My b value is 4, so that's 4 squared. Okay, let's simplify this. Well, I know 3 squared is 9, 3 times 3, and 4 squared is 16. Again, if I simplify, I have 9 plus 16 is going to give me 25. Since I want to solve for x, I'm going to have to take the square root of x squared. So I'm going to have to take the square root on the other side as well. Square root of x squared is x, which is exactly what we want to find. And the square root of 25 is 5. So therefore, our x value is 5. Okay, let's look at the second example. Remember, the side opposite the right angle, that's our 90-degree angle, is our hypotenuse, which is labeled C. The other two sides we can label A and B, and it doesn't matter which one is which. The Pythagorean theorem states that c squared equals a squared plus b squared. Let's sub in what we know. Well, I know c is 13, and I know a is 5, and b is our x. That's our unknown. We're not sure what that side is. Okay, so I need to move everything over except the x. We want x by itself. So if I wanted to move that 5 squared over to the other side, well, I can assume this is plus 5. So when I move it over, I'm going to end up with minus 5 squared. That's going to get rid of that. Now I have 13 squared, which I know is 169, minus 25 is going to give me x squared. And 169 minus 25 is going to give me 144 equals x squared. And again, I don't need to know what x squared is, I need to know what x is. So I'm going to have to take the square root of each side. Square root of 144 is 12, and the square root of x squared is x. So, therefore in this triangle, we were trying to solve for x. Well, x equals 12. And there you have it. The important thing to remember with Pythagorean theorem is that your c value is the hypotenuse, and you need to correctly sub in. So sometimes you will be solving for c, but there are also times you're going to be solving for a or b. So you have to be very mindful of what you're subbing in for.
That's all, folks, and enjoy. Part 7.
Hello there, folks! Today, we will be talking about the world of trigonometry.
What does trigonometry mean in Greek? In this red box means triangle, and this blue box means measure.
Do you know that trigonometry is a study of properties of triangles and their applications? Trigonometry is very useful in the study of engineering. Yes, engineers uses a vast amount of trigonometric function. For example, this famous Isalina Bridge in Cagayan de Oro City. Engineers routinely use trigonometric concept to calculate angles. Civil engineering uses the concept of similar triangles, in which two triangles are said to be similar if their corresponding angles are congruent and the corresponding sides are in proportion. In other words, similar triangles are the same shape, but not necessarily the same size. Triangles are congruent if, in addition to this, their corresponding sides are equal. That's all, and thank you for listening today. This has been Ron Ako, your youth correspondent for today.
Good afternoon, everyone. I am Jimmy Atiu, a chemist from Lourdes College. And how trigonometry relate to chemistry? First, what is chemistry? Chemistry is a study of matter, its properties, and the study of how and why substances combine or separate to form another substances, and how substances interact with energy. The second one, what does chemists do? We chemists research and experiment with the properties of chemical substances. We measure the effect of chemical compounds in various situations and study interchemical reactions. We can study molecules geometry in which trigonometry is applied. The third one, how is it trigonometry used in chemistry? In chemistry, we chemists use trigonometry with accurately describing the angles that are created when atoms bound together to form molecules in molecular geometry. The molecule within a triangular prism so that we chemists can work out the equation that determine the interior angles and length of the triangles in three sides, which are called the opposite, adjacent, and hypotenuse.
For example, molecules want to be as far away as possible from each other when they bound. In figure 2, when molecules spread apart from one another, they create angles.
That's all, everyone. I hope you learned something new. Goodbye! And
Girls, what y'all trying to do? 24 carats magic in the air. Head to toe so clear. Look out! Pop, pop, it's showtime. Showtime. walk in. Showed up wearing Cuban links, designer mix, Inglewood's finest shoes. Don't look too hard, might hurt yourself. Known to give the color red the blues. Woo, shit. I'm a dangerous man with some money in my pocket. Keep up. So many pretty girls around me and they're waking up.
Hello, so my name is Nexus and I'm going to explain in trigonometry about similar triangles. So just watch this.
Hello, I will now introduce to you the concept of similar triangles. Let me write that down. Similar triangles. Oh, I forgot the end. Angles. So, what does similar mean in everyday life? It means two things are similar, they're kind of the same, but they're not the same thing, or something without being identical. And that's the same thing for triangles. So, similar triangles are two triangles that have all the same angles. For example, let me draw two similar triangles. Okay, that's one, and then just smaller. Okay, so we now have two triangles. So for example, this angle right here, this angle is equal to this angle, and this angle up here is equal to this angle. Okay, so you already know that this angle is gonna be equal to this angle. And why is that? Well, because if two angles are the same, then the third has to be the same, right? Because all three angles add up to 180. For example, this is x, and this is y, and this one has to be 180 minus x minus y. But that's the same thing here. This x and this is y, then this angle right here is gonna be 180 minus x minus y, right? So if we know that two angles are the same in two triangles, and we all know that the third one is gonna be the same, so we could do this, and if all the angles are the same, then we know that we are dealing with similar triangles.
Okay, and that's how trigonometry is applied in architecture. Again, this is Nexus, and thank you for watching.
everyone, I'm going to be talking about how can we apply useful trigonometry application to our daily lives. So, what is trigonometry? Trigonometry is the branch of mathematics concerned with specific functions of angles and their application to calculation. So, it's a branch of mathematics concerned with the specific functions of angles and their application to calculation. Trigonometry comes from the Greek word trigonon, means triangle, and metron means measure. So trigonometry is the study of triangle measurement. There are 6 functions of trigonometry. These are the 6 trig functions. These are the hypotenuse, the longest side, the opposite, the adjacent. These are the 6 trig functions: sine, cosine, tangent, cosecant, secant, and cotangent. Purpose. What is the purpose of trigonometry? Trigonometric functions are used in obtaining unknown angles and distance from known or measured angles in geometric figures. Trigonometry developed from a need to compute angles and distance in such fields as astronomy, mapmaking, surveying, and artillery range finding. Astronomy uses trigonometry to find the distance of a star. You cannot just point lasers or any gadget to find a distance of a star. Stars are very far away. It will even take months to using light year speed or speed of light to get into that specific distance. So they use trigonometry and also map making and surveying. So in surveying, let's see how surveyors apply trigonometric functions. Suppose you were trying to measure the width of a canyon from your side to the distant canyon wall. You could not base the distance. Could you come up with a way to make this measurement? Surveyors and geologists encounter these kinds of problems all the time, and over the course of centuries, they have found a simple way to solve this problem. They use the method called triangulation. So in order to let's say you are here and you want to measure the distance over there at that mountain over there. So how can you measure when there is a canyon wall in front of you? You cannot just point laser or gadget or your surveyor gadget. Otherwise, you only be measuring from distance here to here. So how can you come up with a method? So surveyor use this method called triangulation. What is triangulation? Triangulation in surveying. Triangulation is the process of determining the locations of a point by measuring only angles to it from known points at either end of a fixed baseline rather than measuring distance to the point directly as in triangulation. So, triangulation is the process of determining the locations of a point by measuring only angles. So, only angles than rather measuring distance to point directly. So, let's see. So, in order to measure that distance in your here, you need triangulation. So, this is the best representation that I can give to you. Suppose this is a canyon wall and this is, you are here, you're standing over here and you want to measure distance over there. So you cannot measure it because there is a canyon wall. So this is how you do it. You will survey here there to form an angle A, and here you will also survey here to form angle B. So let's see, angle A and angle B. So you have now two angles, angle A and angle B. So you will use this formula to solve for the distance here. B is for baseline. So this is your baseline. Baseline, suppose you have a baseline of 4,828.03 meters. So let's see, 48 meters, sine 62, sine 42. So sine for 62 is 2,852.43, and sine 62 plus 42 is 0.97. So you will divide this and you will come up with this answer over here. So the distance is 2,940.64 meters. So in pyramids, how do Egyptians use trigonometry to find the height of the pyramid? So imagine being an ancient Egyptian. They had no calculators, no computers. They could use only angles in a pyramid side length to find the other side lengths. An early application of trigonometry was made by Thales on a visit to Egypt. He was surprised that no one could tell him the height of a 2,000-year-old pyramid. He used his knowledge of relationship between the heights of objects and the length of their shadow to calculate height for them. So Thales used shadow of the pyramid to calculate the height of the pyramid. So let's see. If you can see, it's form 90 angle over here, and see it's form angle. So it's form triangle. Triangle, and let's see. So recap, this is the height of the pyramid. This is the angle, the adjacent, the hypotenuse. So we need to find the opposite side. So this is the representation. So this is the formula that I will be using in solving another problem using this. So let's solve the height of a pyramid. So let's use, suppose I have this angle, I have this problem given that, and the shadow is over here. The shadow, as you can see here, my shadow is over here. So I'll be using it. Suppose I have 50 meter. So the half, this is 100 meter, and this is also 100. Suppose, so 50 meter adjacent equals 150. You need also to compute or to include this 50 meter over here, 100 meter. And you have given 30 angle and the height, and you need to find the height. So I don't know the height, so I'll place that as h, and I am given the adjacent, which is 150 meter, and the angle. So what does the trig function that has an opposite side, that uses opposite side, and adjacent? So So we cannot use it because we have opposite. We are finding the opposite, but we don't have the hypotenuse. So we cannot use that. Neither 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 we cannot use this also because we're not finding adjacent or hypotenuse. We can use tangent because we're going to find opposite and we have adjacent. So let's use that. So here tangent 30-degree height over 150, you cross multiply this and you will get this you will come up with this equation and you can just calculate it into your calculator. So there you will see height is 86.60 meter. In architect use also trigonometry for their designs to calculate. Suppose here, suppose the architect or the civil engineer use this architect to come up with this triangle. So they measure the angle. I mean, they will also measure or form a measurement of this angle. So that's how they use trigonometry. They can also use it in many forms. So in astronomy that I am talking about before, they use also triangles to measure the distance of a star, Venus, or anything. So as you can see, distance from Venus, it is very far away. As you can see, it's 105 million kilometers away from the sun. So that's how they use trigonometry. So in my previous project, I used this periscope. I make this periscope. It also use angles, measurement of angles, so that you can see through an obstacle. As you can see, it forms angles. This is called 45-45-90 angle concept. As you can see, 45-45. Periscope is used in marine or in submarine. Submarine immerged in water, so they cannot see the surface. So they use this periscope so they can see objects like here. As you can see here, they can see the boat over here. They can see the ship. So it will minimize collision. So that's it, folks. There are many useful trigonometric application you can use in trigonometry. You can use it in anything. It is used in engineering. It is used in finding the length or any other forms. It is also used in what's called that flight in the airplane. Pilots use trigonometry to find the distance of point A to point B. So that's it, folks. This ends my discussion, and thank you. Thank you, everyone.
Hi guys, I am Jason and I am here to talk about the applications of trigonometry in our daily lives. First, let us define trigonometry. Trigonometry is a branch of mathematics that deals with the relations of the sides of the angles of a triangle. For now, I'll focus on discussing the trigonometric functions. So, trigonometric function is a function of a triangle expressed as the ratio of the two sides of a right triangle that contains that angle. Trigonometric functions has three parts: sine, the cosine, and the tangent. Sine is the ratio of the opposite over the hypotenuse. Cosine is equals to the ratio of the adjacent over the hypotenuse, and tangent is the ratio of the opposite over the adjacent. There are the three functions that are not often used and can be derived from the three primary functions: cotangent, secant, and cosecant. So that's it. I hope you learned something from this video, and again, my name is Jason and thanks for watching.
Hi, I am your civil engineer Naidi. Today, I will tell you how important trigonometry in our field. What is trigonometry? Trigonometry is a branch of mathematics that studies relationship involving angles, lengths, and triangles. Engineers use trigonometry concept to calculate angles. Civil engineers all use trigonometry to calculate forces on objects, such as bridge. They are the ones who calculate bridge. And also the calculation of static forces on an object that is not moving. For example, this one, the bridge. Civil engineering is a professional occupation involving the design, construction, and maintenance of naturally and physically built environment like bridges, dams, roads, tunnels, and buildings. Without civil engineer, there is no bridge to connect us.
Dos caliente, dos caliente, dos caliente. 1, 2, 3, 4. Mueve, mueve el cadera. Mueve, mueve el cadera. Move your hips, move your hips.
Everyone, I am Mahili friend C. Fuentes, and I am going to talk about the application of the trigonometry in the other field. We all know that trigonometry is everywhere, so one example is the civil engineering. Civil engineer relies on a triangular support when an engineer determines the length of the cables, the height of support towers, and the angle between the two with gauging weight, looks, and bridge strength. Trigonometry helps them to calculate the correct angles. It allows builders to correctly lay out a curved wall, figure the proper slope of a roof, or the correct height and rise of the stairway. That's all, and thank you for watching.
Discuss about unit circle. Mathematicians create definition because they have a use in solving certain kinds of problem. For example, the 6 trigonometric functions were originally defined in terms of the right triangle because that was useful in solving real-world problems that involve the right triangle, such as finding angles of elevation, domain, or set of input values. Of these functions, the set of angles between 0 and 90 degrees. We will now learn new definition for this function, in which the domain is the set of all angles. The new function will have the same values as the original functions. When the input is acute angle, in a right triangle you can only have acute angles, but you will see the definition extended to include other angles. One use for this new function is that they can be used to find a known side length and angle measure in any kind of triangle. This new function can be used in many situations that have nothing to do with triangles at all. Before looking at the new definition, you need to become familiar with the standard way that mathematicians draw the label angles. That's all for today. I'm Willie. Thank you for watching.
Hi guys, welcome to the world of trigonometry. Now I'm going to talk about the application of trigonometry in criminology. So, trigonometry in criminology. Criminology, or the scientific study and investigation of crime and criminals. Did you know that criminology involves a surprising amount of trigonometry? When investigating a crime, there are many crucial pieces of information that can be found using trigonometry that could end up helping professionals solve a case. Trajectory of a projectile. We look at how we can tell the path of projectile, like an arrow or a bullet, from trigonometric graphs and ratios. Trigonometry could be used to find the angle at which the bullet is fired, where it was fired from, or the speed at which the bullet was fired. These can all be incredibly useful information when investigating a crime scene and looking for clues that could lead to the criminal. So that is the trigonometry in the field of criminology. Thank you. This is Gerald M. Nagita. Thank you for watching.
Hi everyone, I'm Rick Anthony Laude, a third-year student taking up Bachelor of Science in Information Technology. Today I will be discussing one of the fields in which trigonometry can be applied. Particularly, I will be discussing about trigonometry in the field of construction. Trigonometry spreads its applications into various fields such as architects, surveyors, astronauts, engineers, and even in the field of construction. It involves studying and calculating angles in 3 dimensions. Construction workers utilize trigonometry extensively in order to calculate the best way to build projects that are stable and safe. There are few examples of trigonometry being used in construction jobs would include: first is foundation of houses, calculating bridge length, and the last is determining roof structures. Foundation for houses. When construction workers lay the foundation for a house, they rely heavily on trigonometry to make sure that the foundation is level and stable. Because the ground is usually sloped and uneven, contractors must use trigonometry to determine the angles and volumes needed to cut and fill the areas of the ground in order to make it level. Calculating bridge length. In a bridge construction project, trigonometry is essential for determining just how long a bridge needs to be. A contractor might use right angle properties and tangents to determine how wide a river is, which directly determines the length of a bridge. And lastly, determining roof structures. The angle of trusses, which provide support for holding up roofs, and the length of rafters in the roof are determined using trigonometry. For example, in a triangular shaped roof, if you already know the length of the rafters and the horizontal length of the roof, you can use the law of cosines to determine at what angle the trusses should be cut for maximum support. If you know the height of the roof and its horizontal length, you can also use trigonometry to determine how long the rafters should be. That will be all. I hope you learned something from me. Thank you and God bless.
Good day! Praise be Jesus and Mary. I am your architect, Jean A. Lopez. Today, I'll be going to discuss trigonometry related to architecture. First, what is trigonometry? Trigonometry is the branch of mathematics dealing with the relations of the sides and angles of triangles and with the relevant functions of any angles. What is trigonometry used for? Applications of trigonometry, besides other fields of mathematics, trigo is used in physics, engineering, and chemistry. Within mathematics, trigo used primarily in calculus, which is perhaps its greatest application, linear algebra, and statistics. How trigonometry is used in architecture? Trigonometry can be used to find the length of the wall. You could solve this by using tangent. This is another example of how architects use trigo to see far of something is. The trigo ratio you could use would be sines. Now, I'll be going to give you 2 examples problem of trigonometry related to architecture. Problem number 1. But first, let us recall the Pythagorean theorem, or the special relationship between the lengths of the sides of a right triangle using the following formula. A squared plus b squared equals c squared. Calculating distance. Frequently, the Pythagorean theorem is used to calculate distances that are not easy to measure directly. In the diagram, a ladder that is 40 feet in the length is placed against a building. The bottom of the ladder touches the ground 8 feet from the base of the building. How high above the ground will the ladder touch the building? First, let us identify the right triangle in the diagram. In addition, identify the legs and hypotenuse of the right triangle. Now that you are correctly set up your equation, solve for x, express your answer as an irrational number, and then approximate to the nearest whole number. The answer is x is equals to square root of 1536 feet equals 39 feet. Problem number 2. At 57 height from the base of a building, you need to look up at 55 degree to see the top of a building. What is the height of the building? To solve this problem, tan times 55 degree equals height over 57. Height equals 57 times 55 degree is equals to 81.4. The height of the building is 81.4. Thank you for watching. I hope you've learned something from this video. God bless us all.
I got that sunshine in my pocket, got that good soul in my feet. I feel that hot blood in my body when it drops. Ooh, I can't take my eyes off of it, moving so phenomenally. You're more like the way we rock it, so don't stop. And under the lights when everything goes.
Discussing to you on how does flight engineering related to trigonometry. Flight engineers have to take in account their speed, distance of the wind. The wind plays an important role in how and when the plane arrives. Wherever needed, this is to solve vectors to create a triangle using trigonometry to solve. So trigonometry will help to solve for the third side of your triangle, which will lead the plane in the right direction. The plane will actually travel with the force of the wind needed to its course. So I'm gonna give you an example on how this trigonometry applied in flight engineering.
So for example, assume that the rescue helicopter can travel at a speed of 100 knots and a 20 knots wind is blowing in a bearing of 90 degrees. The knot is the standard unit for measuring the speed of an aircraft, and it is equal to 1 nautical mile per hour. So, for example given the diagram, as we can see, the aircraft speed, which is consists the 100 knots, belongs to the hypotenuse, and the ground speed, which is the adjacent, is equals to unknown. And while the wind speed is the opposite side, which is the wind speed is equivalent to 20 knots, and it has a 90 degrees. So the formula is c squared is equals to a squared plus b squared minus 2ab cosine c. C is the degree of the angle. For example, the solution of this is, and the answer is to find the ground speed. So here, the ground speed. So we can quickly and accurately determine the ground speed and course using a sketch to visualize the problem as shown in Figure 1. Anticipating the effect of the wind, the helicopter needs to fly on a heading aiming at the point B that is slightly more northerly than the mountain point C. So, using the cosine rule, we can find the ground speed B. So, 100 knots here, which is U squared, is equals to 10,000, is equals to 20 squared, equivalent to 400, plus B squared, copy, minus 20, which is the wind speed, consists of 20 knots, B, then cosine 90. 90 is the degree of the angle. So the answer is B squared minus equal to 0B minus negative minus 9,600 is equals to 0. So this is the quadratic formula.
and the given is a is equals to 1, b is equals to 0, then c is equals to negative 1,600. So x1 is equals to 97.97, so on and so forth, and the x2 is negative 97.97, so on and so forth. So we're gonna get this answer in order for us to know the ground speed. So the formula is, so using the standard formula for the solution of the quadratic equation and taking the positive rule, now that we know our ground speed, we can use the sine rule to calculate the heading the helicopter should follow. So sine B is equals to B sine C divided by C. So sine B is equals to 97.97, which is coming from here. Then sine 90 divided by 100. So B is equals to 0.9797 degrees. So with this result, we can conclude that if the aircraft takes a heading of 0.9797 degrees with a speed of 100 knots under the effect of a wind blowing towards the south with a speed of 20 knots, it actually reduces the ground speed of the aircraft to 86.93 knots.
That's it. That is the example on how does trigonometry apply in a flight engineering. So I hope you have learned something about how does flight engineer related to trigonometry. Thank you and God bless.
And I will be discussing about how trigonometry can be used in our daily lives. So first, let us define trigonometry. Trigonometry is a branch of mathematics that studies relationships involving lengths and angles of triangles. So in this video, I will be discussing the 30-60-90 and the 45-45-90 triangle. So first of all, a right triangle is a triangle that has exactly one right or 90-degree angle. So this specific kind is a 30-60-90 triangle where the two acute angles are 30 and 60 degrees. So the 30-60-90 triangle is special because of the relationship of its sides. Hopefully, you remember that the hypotenuse in a right triangle is the longest side, which is also directly across from the 90 degrees angle. The 45-45-90 triangle is a special type of isosceles right triangle where the two legs are congruent to one another and the non-right angles are both equal to 45 degrees. So note that it's the shape of half a square cut along the square's diagonal and that it's also an isosceles triangle which both legs have the same length. Many times, we can use the Pythagorean theorem to find the missing legs or hypotenuse of 45-45-90 triangles. So next, I will be showing you a video that explains what trigonometry really is and its importance in our daily life. Thank you and enjoy. what trigonometry really is, and I hope you really like the video and learned something from it. You can add me on Facebook, Ravnish Malini, or Twitter at RVMLHI. So thank you everyone and have a wonderful day.
Oh, hello! I didn't see you there. Sorry, I was doing some maths. Hi. My name is Janine Maxon, information technology expert. And today I'm going to be talking about trigonometry in a field called architecture. So what is architecture? Architecture is the designing of buildings and structures like, you know, skyscrapers and houses and train stations and just structures.
Yeah.
So you know, trigonometry was used even in ancient times. In Egyptian times they were using trigonometry to make pyramids and stuff like that, and they're still standing today. They use the trigonometric functions like tangent, sine, and cosine. The way those work basically is sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. So what information can you get from trigonometry that can help you make buildings and structures? Well, I'm going to tell you today. When you're making a building, sometimes you need to get the height. And if you need to get the height, you can, for example, here's a triangle here. This is the height of the building. And then here is the shadow away. And here is the hypotenuse. And then you can just see this angle right here. You can just get this angle, and you can measure the length of the shadow, and then you could figure out the height of the building by using a trigonometric function. Other than that, you need to understand forces like vectors that are acting on the buildings in trigonometry also. The vectors have to have a starting point, magnitude, and direction. You need to get a vector's components if you express it in terms of the angle it forms relative to an axis. And you know, modern times we use trigonometric functions to calculate things in buildings, but we also use calculus and geometry, everything piled together to make the best building that you can make. And by the way, what's the tallest building in the city? It's the library, because it has so many stories.
Hello.
Okay, I'm not funny. But nowadays, with the power of you know, programming, IT, we can use simulations to make buildings that automate all the math and problems and stuff. But that still uses calculus, trigonometry, and geometry. But it's less work on the architectures, because you know, back in the day they had to do all that stuff manually, and now we can just use technology. So that's the advantage of today. And I guess if you use a computer, that's less room for errors. And yeah, that's about it. That's about everything you need to know about trigonometry in architecture for now. But just stay tuned, because this video is not over yet.
Yeah. Also Doug XP. Kalimutan mo na yan, sige maglibang. Huwag kang magpakaibang, dapat ay itawa lang. Ang problema sa babae, dapat tininda. Hayaan mo silang mag-abol sa'yo, diba? Sabi ko naman sa'yo, lahat yan nagloloko. Pagkatapos ka pa kinabangang bigla lalayo. Kaya wag nang uulit pa. Kaya wag nang uulit pa.
Tayo, kailan ka ba matututo? Pag-ibig ay sakit sa ulo, kaya huwag kang magpapaloko. Bakit ba ang bilis mo na maniwala dyan? Di ka pa ba nadala sa iyong nakaraan? Ilang beses pa ba nakitang papayo?
Good day everyone, praise be Jesus and Mary. Today I am going to discuss how civil engineers use trigonometry concept in their field. Trigonometry is one of the more usual maths for engineers. A civil engineer whose training or occupation is in the design and construction, especially of public works, such as roads or harbors, because civil engineers deal with design, they need to apply trigonometry in their process of designing. By applying the principle of trigonometry, engineers can calculate such as data as the height of an existing structure, the measurement of an angle, or the distance between 2 points. Trigonometry is used in building plans. It is used in calculating dimensions such as height, width, and angles. Trigonometry can also be used in determining the structural integrity of a structure. As an engineer, you need to design the cable supporting the bridge deck. An initial analysis shows that the concrete tower is 175 meters above the road deck and that the support point for the main cable is 125 meters away from the concrete tower. How long does the cable have to be? In order to know if how long does the cable, we need to use the Pythagorean theorem, which is a squared plus b squared is equals to c squared. Our a here is 125 meters, which is a support point for the main cable, and our b is 175 meters, which is the concrete tower. So 125 squared plus 175 squared is equals to c squared. 125 squared is equal to 15,625 plus 175 squared, which is equal to 30,625. So 15,625 plus 30,625 is equals to c squared, which is 46,250. Square root of 46,250. For us to get the c, we need to get the square root of 46,250, which is equal to 215.06 meters. You would design a cable that is 215.06 meter long. So that is the measurement of the cable. That's how civil engineers apply trigonometry concept to their design process. The calculation of dimensions like length, height, and width come into play. Also calculating angles, building scale, models, and determining the structural integrity of a construction is essential in the designing process.
Everyone, praise to Jesus and Mary. Today, I am going to discuss how marine engineers use trigonometric concept in their field. Trigonometry is fundamental to navigation. It is used extensively in calculation referring to Cartesian coordinates. Cartesian coordinates are used to represent the north, the south, the east, and the west direction. Trigonometry is used to build and navigate marine vessels. To be more specific, trigonometry is used to design the marine ground, which is a sloping surface to connect lower and higher level areas. It can be a slope or even staircase depending on its application. What these engineers usually do? They build and repair ships, for example, are the boats you see on lakes, the boats the military have.
I'm more than a summertime lover.
Sample problem.
The captain of the Titanic is facing a problem. There is an iceberg in the way of the road they were taking to America. He needs to figure out which degree to turn the ship in order to be free of the danger. Find X and save the Titanic. Tan X is equal to opposite over adjacent. 22 over 42 is equal to 0.5238. Tan is equal to negative 10, 5238. 2764 is equivalent to 28. So the Titanic must move course by 28 degrees.
Hey everyone, praise be Jesus and Mary. Today I am going to discuss how mechanical engineers use trigonometric concept in their field. Trigonometry is not just a subject to be studied in a classroom with no real-world practical applications. Engineers of various types use the fundamentals of trigonometry to build structure, systems, design bridges, and solve scientific problems. Engineers must have an understanding of an angle and planes, as this is one of the most common applications in their job. Mechanical engineers make use of the mathematical understanding of planes to break down curvatures, patterns, or electrical fields into mathematical terms. Mechanical systems can be imagined and drawn in mechanical terms, and problems in these systems can be solved with geometric understanding. Mechanical engineers use trigonometry to calculate torque and forces in objects, such as bridges or building girders. In particular, it is used in ratios, force, triangles, displacement, and dimensional studies. Here is our problem. If the machine has a height of 5 feet and the length of 7 feet, what is the length of the hypothesis? So in order to solve this problem, we will use the Pythagorean theorem, which has the formula a squared plus b squared is equals to c squared. So first, we will get the square of the two measurements. First, 5 squared plus 7 squared is equal to c squared. The square root of 5 is 49, while the square root of 7 is 25. We will going to add 49 and 25, so the answer is 74. After that, we will get the square root of 74, and that will be our final answer. So the square root of 74 is 8.6 feet. The hypothesis is 8.6 feet long. Trigonometry is a branch of mathematics that explores the relationships between the lengths of triangle sides and angles. Engineers routinely use trigonometric concept to calculate angles. Good day everyone, praise be Jesus and Mary. Today I am going to discuss to you how aero engineers use trigonometric concept in their field. There are two main disciplines used for safe ship designs, the calculus and the trigonometry in aerospace engineering. There's an example of trigonometry in aerospace engineering. This example is fairly simple. One can find angle at which a glider will ascend or descend using trigonometry. What is a glide angle? A glide angle is an angle at which glider descends at its travels. If the vehicle is gliding with no external forces acting upon it, like engines, heavy winds, or etc., it will follow the hypotenuse on the right angle. Since it's a right triangle, all you have to do is to find the hypotenuse. Let's say one knows the distance they want to glider to travel and the height they want to start from. Then you have two sides of a triangle and can find the tangent of a glide angle. So the equation would look like tangent multiplied by angle equals distance over height. Without trigonometry, it would be nearly impossible to land or navigate a spaceship throughout Earth and space.
Thank you for watching. We hope you learned something new. Bye!
For you in your darkest times, I was there for you in your darkest night. But I wonder where we are when I was on my worst, down on my knees, and you said you had my back. So wonder where we are. All the roads you're talking about to me. So I'm following the map that leads to you. The map that leads to you. Ain't nothing I can do. The map that leads to you.
Hello everyone, welcome to the world of trigonometry. Did you know that flight engineers have to take in account their speed, distance, and direction along with the speed and direction of the wind? The wind plays an important role in how and when a plane will arrive. Wherever needed, this is solved using vectors to create triangle using trigonometry to solve. For example, if a plane is traveling at 234 mph 45 degrees north of east and there is a wind blowing due south at 20 mph, trigonometry will help to solve for that third side of your triangle, which will lead the plane in the right direction. The plane will actually travel with the force of wind added onto its course. I am Luella B. Kiderho. Thank you for watching.
Hello everyone, welcome to the world of trigonometry. Now I will be talking about the application of trigonometry in marine engineering. So did you know that in marine engineering, trigonometry is very crucial and useful to build and navigate marine vessels?
So to be more specific, trigonometry is used to design the marine ramp, which is a sloping surface to connect lower and higher level areas. It can be a slope or even a staircase depending on its application.
This is Chris Dayan and Pixalas. Thanks for watching and I hope that you've learned something about this video.
So, good evening guys. I am Anjanette Reyes and this is my explanation in terms of trigonometry and game development. When you talk about trigonometry, what comes in your mind when you hear the word trigonometry? For me, trigonometry consists of triangles, angles. It consists of calculations involving triangles and their heights, lengths, and their angles. So, trigonometry began in 3rd century BC before Aristotle and Archimedes. So, trigonometry is mostly used in the modern world, especially in today's generation, for the millennials. Trigonometry is used in many ways, like astronauts, engineers where they build buildings, what you call this, astronomer, in science, even in the math and physics. Trigonometry is very important as part of our lives. So, right now, let me explain to you what is trigonometry in terms of game development. If you want to know more about trigonometry in game development, keep watching the next video. So as you have seen all the examples before in the game development, Circus Charlie and Super Mario. So when programming a game, the positions and speeds of objects needs to be written using X and Y. Finding the positions and speeds of objects involves the use of triangles. Trigonometry is used extensively in game development in order for the game to function. Also used for designing objects, characters, and sets. Imagine you are designing a spaceship game and you decide you want to move the ship to the red X. We know the radius and the number of degrees we want to go around the circle when programming. We need the X and Y coordinates. Trigonometry can also be used to determine the speed that an object is moving. It can be used to rotate an object, search trigonometry in game development.